Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Fairwinds. My name is Cody, and I'd love to welcome you back to Techstrong Learning. We've got an exciting panel, but before we get things kicked off, we do have just a couple of housekeeping notes I'd like to review. First, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of options for you to do so. First of which is the chat tab, which you'll find on the right side of your screen. I'd like you to go ahead and start testing that out for us by letting us know from where in the world you are tuning in from. If you have any specific questions for us, we do want you to direct those to the Q&A tab directly to the right of the chat tab. Sending your questions to the Q&A just helps us keep track of them and answer as many as we can. So please do send in your questions early, often, and in the Q&A. We've got a couple of polls that we'll be launching throughout today's program. It looks like they're on about slide 4 and slide 11. So those are your call points where we need your attention for some responses. And of course, before we close things out today, we are going to be giving away 4 $25 Amazon gift cards. So be sure to stick around. All right, so the topic are 4.
That's exciting. 4. Dang. Okay. Keep going.
Well, our topic today is 6 tools you need to use with Kubernetes, and my joy-filled panel today is Kendall Miller, technology evangelist at Fairwinds, Andy Suderman, CTO at Fairwinds, and Stevie Caldwell, tech lead at Fairwinds. So Kendall, Andy, and Stevie, always a joy having you with us. Kendall, you want to go ahead and get this thing kicked off?
Yeah, let's go ahead and jump in. Thank you, Cody. And I'm excited that there's 4 that we're giving away, but I feel like maybe we should have done 4 tools so we could have 1 prize per tool. Anyways, it's okay. We're going to talk about a whole bunch of tools today. We're actually going to be talking about 6 categories of tools, of things you need to use with Kubernetes. So the kinds of tools, and then we're going to go into some specifics about each category of tools. So, instead of saying you should bring blue crayon, we're saying you should bring colors, and we're going to talk about crayons and markers and paints, and it's going to be exciting. None of those are Kubernetes tools, so if you feel lost, don't worry. I'm using a ridiculous analogy. But let's go ahead and dive in. First, my name's Kendall. I am a tech evangelist here at Fairwinds. I've been involved in the company for a very long time, a very, very long time, almost as if from the beginning. And excited to be here and talk with you about Kubernetes. Andy, you want to introduce yourself?
Sure. I'm Andy. I'm the CTO here. I've been here not quite as long as Kendall, but longer than just about anybody else besides Kendall. Kendall, I think you said your name wrong. It's Kendall Miller, according to the slide. I'm Andy Suderman.
That is amazing.
Yes. But anyway, I've been working with Kubernetes for, I think, 7 years at this point. I've been with the company for 5. I'm an author and maintainer of several of our open source projects, and excited to talk about Kubernetes all the time. So I'll hand it off to Stevie. Stevie.
I'm Stevie Caldwell. I say real quick, this reminds me of back in the day, there was a phone line you call movie phone to find out when a movie was playing. And when Tomb Raider came out, the original with Angelina Jolie, we would always laugh. It was an ongoing joke because you would call that line and it would say, here are the show times for Lara Croft Tomb Raider. And that's what it feels like when we say our names like that. Anyway, apropos of nothing, I am a tech lead here at Fairwinds. I've been here slightly less than Andy, I think. And I think we're all feeling a little punchy today. So you all are in for a treat.
Is this unusual for us, Stevie? Are we not always punchy like this?
This is a bit of a
stepping it up. Yeah. Well, okay. Well, before we get in too deep, we are going to pause and have a quick polling question. How much of your infrastructure is on Kubernetes today, or is planned to be migrated in the next 6 months? And we have made this question very easy to be none, some, half, or all of it. And if you are near half, you are welcome to answer that. If you are near none, you can answer that. Like 1 or 2%, you can say none if you'd like to, though technically it is some. but we're just trying to get a feeling for approximately how much Kubernetes usage people are using. Go ahead and click a button there.
Answer A.
Answer A.
I answered A.
A.
You answered.
None, some, half, all of it. And let's see how the poll's coming through. As these numbers come through, oh, there we go. Now we're getting some responses. There we go. How much of your infrastructure is on Kube? Wow, this is a good show right here. 14% of you saying none, 48 saying some, and 24% saying all of it, with the haves matching the nones. That's interesting. Well, we're glad that you either have something in Kubernetes, or you're thinking about having something in Kubernetes, or you have some things in Kubernetes. As actually, it doesn't surprise me that more people have some than all of it, because there's in any sufficiently large organization, there's something running in COBOL on a mainframe somewhere. And I hope for all of your sake that none of you work at organizations that are like that, but I recognize that's a reality.
My dad still runs an AS400. It's out there.
Somebody's got to run them. Somebody's got to run them. And so before we dive into this, the reason we're here talking to you about this is because the three of us work at Fairwinds. All Fairwinds does is Kubernetes. We build and maintain Kubernetes for people. We help people with Kubernetes problems, and we sell people Kubernetes software, because everybody's sitting around going, hey, we heard Kubernetes is cool. We'd probably like to use that. And then immediately think, but I'm probably going to use it wrong. Is there a way I can avoid making all of the rookie, terrible first-time mistakes? And the answer is yes. We have software for that, open source for that, services for that. If you're using Kubernetes, Fairwinds has something that will make your life wildly better, or save you money, or no, those are the ones. You're both. Thank you, Stevie.
Both is good.
Both is good. Both is good. Okay. So let's dive in. We're going to talk about a couple different categories of the kinds of software you're going to want to use with Kubernetes. Now, bear with us. Some of this may seem wildly obvious to you if you're currently using Kubernetes. Some of this won't if you're not, or it may be new paradigms. It just wasn't that long ago that we were writing software and burning it to CDs and carrying it to our server room and installing it on one machine, and then installing it on the next machine, and then installing it on the next machine, and then going back to our desks and emailing that day's source code to the chief engineer who tried to reconcile it all before the next workday. So we've come a long ways, and forgive me if some of this feels obvious to you, but I continue to be impressed with where we're at. So let's start with CI/CD, because it doesn't matter if you have Kubernetes if nothing's running in Kubernetes. So at some point you need to deploy, and probably you need to integrate in the process of deploying, and hopefully you do it continuously. So real high level, Andy, what is CI/CD? I assume everybody knows, but give the 2-line, and then let's dive into what Argo is, why it's different, how people are thinking about some of these things.
Yeah, I mean, like you said, you've got to get your software from the code into wherever it's running. And so, we continuously integrate code into our code base, that's CI, and we need to hopefully continuously, or at least on some sort of like regular basis, deploy that code into the cluster. And so there's a lot of different ways to do it in different ways. We used to just use a collection of bash scripts that was a little bit of an opinionated way of building a Docker container, pushing it to a registry, and then doing a Helm deploy of a Helm chart into your cluster every time you merged code. And that worked really well for us for years. And we still do that in some places. But now we have GitOps tools out there that I think provide quite a few benefits over, Bash, and give us the opportunity to run CI/CD in our clusters with pull access to our repositories and be continuously monitoring that code. So Argo CD and Argo Workflows is one way to do that. Flux is another. Those are kind of the two big tools out there that I see for GitOps. Both have their pluses and minuses. I've heard great things about both. I don't think I could solidly recommend one over the other, but we use Argo CD here quite a lot these days, and we've been big fans of it.
What's different about GitOps workflows. Just talk for a second about push versus pull, why that matters, why this is maybe another step in the world of this whole declarative thing that we're doing, and actually, yeah, we'll start with that.
Do you want me to do that, or Stevie? Do you want to take that one?
Stevie, why don't you take that one?
Sure. So, what do we say? Push versus pull. With Argo CD, and I assume with Flux, although I'm not familiar with Flux because, as Andy said, we use Argo internally. One of the benefits of doing like a GitOps approach like this is that your code base is your source of truth. And so you said essentially it's like a reconciliation loop, which helps prevent unwanted changes on your live cluster. And make sure that someone can essentially look at your code repo and know what the state of the state of the application in your cluster is supposed to be. And the way we use Argo, even more so, we use it to apply. We template out Helm manifest or manifest for cluster objects using like Helm templating. And that allows us to, when we run Argo, to actually see things like, what is happening, to be able to do PRs and see live in our PR, like what the exact changes are versus the way that it can be sort of hidden if you use the built-in Helm functionality in Argo. But ultimately, it's about making sure that you have a source of truth that is easily seeable, easily reviewed, and Argo essentially does a reconciliation loop where it is checking against manifest somewhere in your code repo and checking against what's running in your cluster and putting things back right again, which can be a little frustrating. I will say that there are times when it can be frustrating if you forget that you're running Argo or something like that, and you need to make a live change, like, for some emergency situation.
Kubectl edit, save,
right.
Get reverted, what happened?
3 a.m. You're like, yeah, I'm just going to go ahead and bump these resources up. And you're like, wait a second, that's not going to work.
Yeah. I think one of the other benefits that I like about GitOps is the security model gets turned around a little bit because it's pull instead of push. So I don't have to worry about putting credentials in my CI system anymore. So if I'm running something like, Circle CI and running in their infrastructure, I don't really need to worry about putting credentials there anymore. It's just that my cluster needs access to my Git repo, which, there's arguable non-benefits there, but I think it's a little bit easier to control access to the cluster and just give it access to one code repo and then control access to the code repo separately than it is to maintain solid, secure credentials within your CI system. CI systems are it's kind of a treasure trove of secrets, right? Like there's secrets to everybody's production environment in these CI systems, but by turning the security model around, we eliminate that sort of treasure trove of secrets. So it's one of the things that I like about it.
That's true.
And the continuous reconciliation is huge because, if every time I merge to main, do a Helm deploy, well, that goes out there once. I know it worked, but like if, Joe over here or Kendall goes into my cluster and breaks something, it's not going to get put back. So,
right.
And don't think I won't go break things, because I'm running all of my everything as root, and everything has access to everything all the time because it's just way easier that way. That's why they don't let me near client infrastructure. And Flux is the same approximate model, right, as Argo. Is there anything fundamentally? It's just a different tool that does a similar kind of GitOps workflow. But GitLab CI, Circle CI, Travis CI, those are in the more traditional realm of push things out, and GitHub has a thing too for that. GitHub Actions or something, right? Would also do that. Yeah. Okay.
And those are somebody for your CI, right? Like being able to build your code, test your code, those kinds of things. They're still super useful there. So
yeah.
And then somebody asked, is Argo fixed to Red Hat, or can Argo run on other Linux distros? And I don't think there's any reason why you can't run that anywhere, right?
Yeah.
Argo and Argo CD are both Kubernetes native and should run in any Kubernetes, environment that you can come up with.
So go see if it works in DSL Linux, because it's my favorite distribution of Linux that probably for the kids I'm not allowed to pronounce the whole name of, but that's okay. If it's supposed to work on anything, I'm just saying. Let's keep going on that note. Monitoring. So I've deployed things into my cluster. Why must I have tools to know how it's going? I mean, can't I just, I'm letting everything run as root. Nothing's going to break. I can just put everything in and not worry about it. No, sorry. Let me say, you don't want to do that. And you do want to know how things are going once you've deployed them, because it may surprise you, but computers break sometimes and go down. And the code that we write is thus far imperfect. Maybe with a few exceptions of some of those things running in COBOL that were obviously written perfectly. In the monitoring side, let's talk about Prometheus. Why is it sort of ubiquitous in the Kubernetes world? What are people using instead of it? And then go on to these other bits. And Stevie, you want to start with Prometheus?
Yeah. Prometheus is like, when you think monitoring in Kubernetes, you think Prometheus, because it has some neat things built into it that are, one of the difficulties of monitoring is that in a Kubernetes environment is obviously that there's so much that moves around. There's so much ephemeral. You've got things scaling up and down. You've got pods going from node to node. And so Prometheus has been really well situated from the start. It was and built to like be able to sort of track those things for you and follow those things, and surface those metrics easily across pods coming and going and nodes coming and going and things like that. And Prometheus is really cool. There's lots of different ways you can install it, and there's I think the most common is there's the Prometheus stack itself, which if you install it, I think with passing nothing in, will put a whole lot of stuff in your Kubernetes cluster. The Prometheus operator, the necessary CRDs, alert manager, Grafana, all that stuff. Set up a whole mess of monitors out of the box for both your control plane things, so API server, latency, etcd, and all the kube state metric stuff. And then we'll also use cAdvisor to pull metrics from the kubelet, or to pull metrics about the resources being used for all the workloads, for your pods and stuff like that, network metrics. And then there are service monitors that Prometheus leverages that allows you to automatically add new things to the Prometheus stack when you deploy them to your cluster. If you set up a service monitor with the proper labels and all that stuff, Prometheus will automatically pick up the new thing you deployed and be on its way. And it's standard these days for most workloads to have Prometheus endpoints exposed. So even if you don't have Prometheus installed in your cluster, if you go to a particular, I think it's the /health Z port or something like that, on your on a workload, like a common workload, like Nginx, for example, you'll see all the Prometheus metrics there, because most of these things are instrumented to expose metrics in a style that Prometheus can read. And there's also a ton of exporters that act as middleware between things that don't have Prometheus metrics exported and Prometheus itself. So there's Prometheus is a big ecosystem that's just ready to go and ready to give you probably more information than you actually need right out of the box, and super easy to install. And I think that's one of the reasons why people use it. It's free, right? And you just you can literally install it and go. It's probably not going to be super useful for you if you do it that way, because you will get inundated with alerts and things like that aren't necessarily actionable. But yeah, it's purpose built for this, I think, is why.
Mm-hmm. Yeah, and part of the reason it's so ubiquitous, I think, too, amongst all the different services running Kubernetes, that all the things you might add on to Kubernetes, is they've made the developer side of it super easy. So instrumenting your application with Prometheus and emitting those metrics is really straightforward. because it's a poll model. So all you have to do is put up, respond to an HTTP request with a standardized format, and they've got, a whole Golang SDK. You just plug it in, start counting up metrics, and, it goes. So it's really a straightforward implementation from the developer side to do those metrics. And I think that's part of the reason that Prometheus has been so successful. I'll address the second question here. Go ahead, Kendall.
Yeah, go for it. Go for it.
Right.
Good.
So
how good is Prometheus? Go for it.
Yeah, we have a question here. How good is Prometheus in monitoring, making monitoring and observability easier, and not easier, efficient? I think that's an important word here in the question. So Prometheus, as Stevie said, getting it going out of the box, super straightforward. I think there's a couple things that are difficult with Prometheus. One is just getting the raw information down to a usable, effective monitoring state can take some effort. You have, quite a lot of alerts that come out of the box with Prometheus. And, if you install Prometheus right now in your cluster, the whole Kubernetes stack, you'll probably find that about half of those are triggering. And you may or may not care about that. Some of them may need to be fixed, some of them may not, but there's a decent amount of noise that it can generate. So building an effective monitoring stack from Prometheus takes a little bit of effort up front. And then long-term storage with Prometheus is something that's still, I think, a little bit tricky. So Prometheus uses by itself quite a lot of memory to store all of the metrics that it's collecting, because Prometheus itself is a time series database under the hood. And so as with any time series database, if you've ever worked with Elasticsearch or Influx or things like that, how to deal with long-term storage of that data can be tricky. And I know there's projects out there that make this easier now. I think Thanos is kind of a popular one. But you have to have some sort of strategy if you need that long-term data storage to get that out of the cluster and into something more efficient for storing long-term. So that's kind of one of the more difficult things. But immediate, in the moment, monitoring observability, it's a great stack. There's a ton of stuff out of the box, and it's very powerful. So
Prometheus is the best tool that's out there, except for all the other things that are also better at it in certain ways. It's just, this is ops, right? Some things are better, and somebody's asking what are the alternatives. So there's a million alternatives. It just depends on if you want to pay for them, if you want to host them. Datadog does this. Honeycomb can do this. There's all kinds of tools out there.
Yeah.
Monitor, etc. There's a lot of places where you can go get something similar. Prometheus is one of the open source ones. It is tweakable all day long. If you're running Linux on the desktop, have we got a Prometheus for you? If you're running Apple because you want something to just work, maybe plug in a SaaS product and pay for it.
Yeah. If I have the cash for it, I will pay for Datadog all day long. But if I don't have the cash, Prometheus is the answer.
That's a good way to put it. Yeah.
And I mean, there is elk stacks you can build and do that yourself. But somebody's talking about OTel, and we've got OTel on this list. Let's talk about OTel, open telemetry. What is it? Why does it matter? How is it different from just metrics? And bonus points to the first person to say eBPF.
Well, you just said it, so you get the bonus.
Yes. Okay.
So OTel is an open telemetry standard trying to standardize how we do telemetry in general, but tracing is kind of the most common use case that you'll see out there. And so this kind of gets into, when we talk about monitoring, there's different levels of this. We have, we talked about Prometheus for infrastructure monitoring and monitoring your add-ons and things like that. And it can do some application level monitoring. And of course, if you're emitting, metrics and stuff, but it's not really built to do tracing. And so if we get into tracing and application performance monitoring, this is where there's other tools that you may want to plug in or use here. And OTel is kind of the standard the standard open standard for sending those and collecting those. And there's lots of different tools that work with OTel. I know Datadog will consume open telemetry into its APM product. Lots of APM products are adopting the standard. So
what makes
you aware of?
Well, and correct me if I'm wrong. I'm gonna dive in here and comment on OTel, and you might have to say everything Kendall just said is wrong. My understanding of one of the things that makes OTel interesting and tracing interesting versus a traditional, traditionally for monitoring, you're writing logs, right? Hey, I'm doing this right now. I'm doing this right now. I'm doing this right now. And you only get data as often as you're intentionally spitting things out to a log. And what makes OpenTelemetry interesting is you have to re-instrument your applications in order to use OpenTelemetry, but then it's watching every single network request, every single input and output, and it's collecting that data and reporting it without you having to have intentionally, in a logging kind of way, said, hey, I'm sending this variable to this guy now, and here's how that works. And then having another log that says, I received this variable, it didn't break down right here, haha. And so, don't get me wrong, there's always a place for logs. Logs are amazing, but OpenTelemetry is a thing that makes that a little bit different. Kubernetes, the question that came through said, can you comment on OpenTelemetry and Kubernetes? I think part of the reason telemetry became as popular as it did in Kubernetes is because Kubernetes does a lot of things for you. There's good and bad in that. Kubernetes is off doing its thing, and if you really know what you're doing and configuring it, great, you're going to have a pretty good understanding, but Kubernetes is going to be scaling things in ways you don't understand. It's going to be having some network traffic and things that you don't always follow, and so having telemetry in there, doing its thing, collecting everything, whether you've asked it to or not, saves you a few steps, helps you find some problems when problems arise. That's the reason people use OpenTelemetry and Kubernetes. If you have a single application running on a single server somewhere, you don't need OpenTelemetry. If you have two applications running on two servers somewhere, you don't need OpenTelemetry. When you're running a Kubernetes cluster, hotel yourself. Hotel it on the mountain.
Wow.
Wow.
That was pretty good, wasn't it? That was pretty good, wasn't it?
Yes. Yeah, and to be clear, I mean, APM and traces have been around for a long time. It's not a new concept. Yeah. OTel is the first, open standard that's being adopted across all these different products. And so that's why it fits so well into Kubernetes, because now we have a common way to talk about these things. And one thing that I'll correct, I'll just comment on that you said, is that you have to re-instrument your app. That's not actually true, because you can get OpenTelemetry metrics from using a service mesh that does that for you. It will intercept every network call coming in. It won't necessarily be as tightly integrated into your code, and so you may consider instrumenting yourself in order to get a higher level of granularity. But if you just need to know this call went to this service and it took this long to get back out, a service mesh can emit all of those traces for you without having to instrument your application. So a service mesh like that will do that.
This is why we made him CTO. It's because things like that. Okay, let's keep going.
No, I just stuck around too long. That's all.
There's some wisdom in that as a career choice. Okay, policy. So everybody, let's just back up. You've done a couple things. You've stood up Kubernetes, and then you've thought, what do I do next? Okay, I should probably put some workloads into Kubernetes. So you deployed some things in. Now you've thought, I wonder how the things in Kubernetes are doing. And so that's why you implemented monitoring. And then you realized everybody in my organization is a maroon and is making terrible decisions. I would like to implement some policy to keep people from making those terrible decisions. And that's where you're going to end up wanting policy. So policies there, again, if you're running a single app on a single server with one person and that person is you having access to it, you don't need to implement policy. When you have a large organization where there's sprawl and people who don't know what they're doing are going to end up causing problems, think of it as guardrails. You don't want people to fall off the side of the road just because they didn't realize they needed to slow down when they turned that corner, right? And so you're going to put in place some policy. So let's talk about some of the policy tools that we have listed here. And Andy, I feel like Polaris, maybe you should start with Polaris.
Well, first, I want to say, you keep saying if you're one person deploying one app to Kubernetes, just don't do that. Like, Kubernetes is not the tool for you. Like, hey, just, build a container, run it in Google Cloud Run, or stick it on Fargate, or do something like that. Don't run Kubernetes. You don't need that. But if you are in this other scenario where you have all these things, I think it's important to talk about why we need policy. Kendall talked about guardrails, but I think we need guardrails because Kubernetes is not by default secure and efficient and highly available. Like, it tries to do all these things, but especially when it comes to security, all the defaults are very lacking in very many ways, and we can question why that is, but that's not really the point here. So we have an open source tool called Polaris that we built out of all of our years of running Kubernetes clusters and seeing our customers make the same mistakes over and over again about how they deploy things to Kubernetes. So we said, we need to stop them from doing that. And so Polaris is a policy engine. It's based on JSON schema that allows you to say, hey, you can't deploy an app into this cluster without a CPU and memory request, for example. I love to pick on that because it's my favorite thing. But, we have a whole host of built-in policies. You can write your own policies. It has an admission controller. And now we even have a mutating admission controller that allows you to say, like, if my image pull policy for this pod is set to if not present, just automatically change it to always, because there's no point in using the other. And so we can do mutations like that as well with Polaris. So that's Polaris in a nutshell, and why we wrote it.
And already there's a question that says Cavern, not good. I think you mean Caverno. So there is a question tab. I do try to watch both chat and the Q&A. You can put your question wherever you'd like. We'll get to them. Q&A is a little easier, but we'll get to the questions as best as we can. Caverno is a great tool. It's another thing that plays in a similar space, similar kind of idea in terms of a certain number of policies out of the box, etc. It is another option in the policy world. It's probably not on the list because we make a competitor to Caverno, and so when we are putting together our list of policy, I mean, we put competitors in this all the time, but it actually just didn't come up, which is kind of funny. But go ahead.
Yeah. No, Caverno's a great tool. Definitely an alternative to Polaris. I can't really knock it too much, frankly. It's a good tool.
It's a good tool. Stevie, you want to talk about Falco?
Only had one song that was notable, and unfortunately, I don't think had much of an illustrious career beyond that. So, yeah.
If I drop the beat, will you sing the tune?
I'm a dance.
I don't even know who this band is that you're referring to, but I'm not mad because you took it all the way through to performance. Thank you, Stevie. That was
really wow. Okay, that's wild to me. Yeah. I can't hear Falco without immediately that coming to the front of my mind, and I'm sure they're prepared for that, and they make that decision willingly. Yeah, I mean, Falco is it's a tool that it taps into syscall events on your host, and then can do things based on those events. So essentially, I think it comes with a set of rules by default, just like Polaris does, and then you can also provide your own filters. They're called filters, and it can then essentially compare those events against the filters and tell you, like, hey, this thing is violating one of your policies, one of your rules, or whatever, and let you know that stuff. So that's Falco in a nutshell, I think.
I question whether Falco belongs in policy or monitoring. It's kind of a little bit of both.
Yeah.
You're monitoring policies around system level events. So like it does a little bit of both, really. But runtime monitoring, I think, is typically where I put it.
Runtime monitoring. Okay, and then Trivy. I mean, Trivy it's another thing. It's sort of a similar. I mean, there is overlap on a lot of these different categories. What does Trivy do? Why does it fall into policy and/or monitoring? Why would we want to run it?
Yeah. So Trivy does a lot of things now. They keep piling functionality into Trivy, but it was originally a vulnerability scanner. So it would tell you where you had CVEs in your containers. We still use it for that. It will also now do, similar to Polaris, similar to Kyverno, similar to OPA, check your YAML for misconfigurations. And then I think they're rolling TFSec into Trivy, so you can do infrastructure as code policy on more than just Kubernetes YAML. You can do it for Terraform as well. So that covers things outside of your Kubernetes cluster potentially. So yes, we did misspell Trivy. Apologies. I just noticed that. And the slides are a PDF, so I can't change it on the fly.
Does Trivy only have one V?
It only has one V, yes. So we misspelled Trivy.
If it only has one V, it should be Trivy. That's probably my mistake. It's okay.
No, I agree. I agree. That's how the language works.
I've seen this word a million times and apparently never realized there's only one V. That's a little embarrassing. Okay. And but thank you, whoever corrected us. Thank you for putting that in the QA tab so that it was private to us and we could debate about whether or not to correct ourselves. That was really going that extra above and beyond. Appreciate it. Okay. And OPA and Gatekeeper. Why wouldn't I write Rego and why wouldn't I want Rego in my life? Let's talk about that.
Rego is super interesting. I've kind of gotten used to writing Rego, but the way I used to describe writing Rego to developers,
which to back up, sorry, Eddie, Rego is the language that you use to write OPA, which stands for Open Policy Agent, which is really just another standard for implementing policy. It's not specific to Kube, but a lot of people use it in Kube. And all of that said, back to Rego. Keep going, Eddie.
Yes, Rego is a generic policy language. It was developed to write policy for anything. So basically you give it a data structure and Rego allows you to write policy about that using that data structure. So Rego, the way I used to describe it to developers and infrastructure engineers is take everything you know about writing code, like how you would normally write code, and then turn your brain 180 degrees and then maybe you'll understand how Rego works, because it's very much it's just a different way of thinking when you go to write Rego. And if you're used to, typical programming languages like I read a lot of Go, then Rego is a little bit funky to learn. But it is very powerful. And then Gatekeeper is the admission controller that can use OPA policies to do admission control in the cluster, much like Polaris's admission controller or Kyverno's admission controller. Works exactly the same way. You can say, if it violates this policy, just block it from getting into the cluster in the first place. So all of them good tools, frankly, and it's really just how you want to write your policies that determines what you use.
And this person in chat says that they think that's unfair to Rego. We should have been twice as harsh on Rego. I'm sorry that we painted such a good picture. Maybe next time we can do better. We got to keep going because we got 3 more categories we got to get through. Let's talk about service mesh, because I thought Kubernetes was too easy, and so I installed Istio. That's how I'm supposed to do it, right? Why wasn't my CNI sufficient? What is a service mesh? Start there.
Yeah, so a service mesh is a thing that a lot of people think they need and don't necessarily. So service mesh, I apologize if you can hear the yard work crews have descended upon my neighborhood. So yeah, service meshes are, they are a whole different set of like control plane components that work in your cluster and allow you to set like some network policies and do some like Andy said, get some really good open telemetry metrics about like the traffic going between your different components, and also allows you to set some, some policies and some rules and control that traffic in some ways. So Istio is on here. Istio uses Envoy, and is a perfectly good service mesh. Very popular. It was probably like really first on the scene. Also a little complex. And
it only requires 29 custom resource definitions to install Istio, at least last I checked, which was a long time ago.
Right, and apparently the newer version of Istio is a little less cumbersome. But we here do use Linkerd as like our preferred service mesh. Linkerd, I believe, uses its own proxy written in Rust. So Linkerd essentially like inserts, a sidecar for all of your services that you say that you want to mesh. and it intercepts that traffic. And that's why it has all that information. You can do the telemetry, and then you can do all these things with the traffic, like telling you that traffic from pod or container A can only go to container B if it's coming from a certain port number or hitting a certain path on the destination container. There's all kinds of really cool things you can do security-wise with networking if you have a service mesh in place. But it does make your networking a little more complicated, right? And so Kubernetes networking is already complicated. When you start to have trouble with, you're like, hey, this request is taking a really long time, and you've got the whole stack to go through, not including IP tables and all the other jazz, right? So when you add something like a service mesh on top of it, that does that can make things a little more complicated. But there are some really good benefits to using it if you need it for its purposes.
Yep.
Yeah. And console mesh is another option out there. I'm gonna wrap this up because we got to keep going. I want to make sure we get through all of our topics. But I will say part of the reason we land on Linkerd is a friend of mine said, hey, a long time ago, I never forgot this. He said Linux kernels have been around for forever. Docker made them usable by mere mortals. And I think that Linkerd is sort of a similar thing in service mesh world. Service mesh has been around for a little while. Linkerd made it usable by mere mortals. If you are the kind of organization for whom Spinnaker is actually the right tool for CD and CI, you might be the kind of organization that needs Istio. For everyone else, probably you don't. So I'm really looking at you, Netflix, and nobody else.
Yeah.
You're not going to need service mesh if you're not doing microservices, but have app monoliths running inside of your Kubernetes. You might. There's all kinds of reasons you might want to have a service mesh. It's really how much fine-grained control do you need over your networking? That's the short answer. If you need a whole bunch, service mesh yourself. If not, don't.
There's other problems you can solve with the service mesh too. I want to be clear. But the answer to that question, in my opinion, is what problem are you trying to solve? And if the service mesh solves that problem, then you need a service mesh. But don't say, don't come at it with a solution without a problem.
Right. Yeah.
Yeah.
MTLS is one of the problems that people solve a service mesh. Yeah.
So let's move on to resource management and cost. The reason this is significant is we moved to the cloud because it was supposed to be wildly cheaper in total cost of ownership. At least that's what Amazon's calculator told me, and I'm sure that wasn't a lie. And then I picked Kubernetes because it's supposed to manage all the things for me and scale up and scale down, so I'm never overspending, right? And probably not actually right, and probably things are misconfigured, and probably it's all human error all the way down. But at some point, if you're running a sufficiently large organization, a sufficiently large infrastructure inside of Kubernetes, you're going to want some resource management and cost. We touch on this with some of our open source at Fairwinds with Goldilocks. This was the baby brainchild of Andy, who, well, I'll let you say more about Goldilocks and then talk about KubeCost too, but go for it.
I'm going to talk about both of them all at once, and I'm going to sum the entire thing up into one sentence, which has become the definition of my now 5-year career at this company, which is set your resource requests and limits properly. Autoscaling in Kubernetes is completely based on how you set your resource requests, and the stability of your cluster will depend on your resource limits. And so if you can set those two things properly and get them to where they actually need to be and implement autoscaling, you won't need KubeCost or Goldilocks because you'll already know that you're using your clusters as efficiently as possible. But Goldilocks can help you set those properly. It can also give you cost estimates to what that looks like, and KubeCost can do the same. But set your resource requests and limits properly.
And if you need larger scale than that, Fairwinds Insights, our large SaaS product that marries a lot of these things together, has a whole bunch of logic above and beyond what Goldilocks suggests around resource requests and limits. Actually gives you some chargeback information, can help you see which workload across my entire organization costs me the most, how much does it cost me across all the namespaces, which namespace is the most, those kinds of things. And you can be watching for spikes and problems in your infrastructure. So that's another option. And let's get on down to cool new vendors, some fancy things that exist that are out there that you should probably know about. So category 6, to be clear, there are 6 categories of tools that you need to have to run in Kubernetes. We covered 5 of them, and category 6 is you need to always be looking for new tools because these are neat. And let's talk about this. IDP, headlamp, lens. What is an IDP? Why are people talking about this? What are headlamp and lens? Who wants to take that one? Stevie, you want to take that?
I was going to tell Andy I'm going to let him take it.
Okay. So these aren't actually IDPs. I don't know why we put that on there. IDP is an internal developer platform. It's really what you get when you take all these tools that we talked about and you put some guardrails around them, and then you give developers access to your cluster. But headlamp and lens are ways to visualize what's going on in your cluster. They give you sort of nice UIs for looking at things in the cluster. And so they can be helpful. Lens has been around for a little while. They were acquired by Mirantis. They're turning it into a whole like IDP thing that I'm not super clear on what that actually means. And I
think they actually use the word IDE. They call it a Kubernetes IDE, which is interesting. But anyways, keep going. Same idea.
But they're integrating more things as well and then moving beyond that. But anyway, they're ways to look at what's going on in your cluster. So there's other command line versions of that. There's K9s or K9s. I don't know how people say it. That is like a text user interface, a TUI for that that I've used in the past. And then Argo CD gives you a nice dashboard. So there's lots of different ways to see what's going on in your cluster across different tools. And then I can talk about Base Image Finder because we just released it the other day and I'm very excited about it. So Base Image Finder gives you, step back. So we use Trivy, we scan our containers, we see that there's a lot of vulnerabilities across all of our containers, and we go, how do we fix this? And sometimes the easiest way to fix that is to upgrade the base image version. So if I'm using Alpine 3.17, there's a critical vulnerability in Alpine 3.17, and I need to upgrade to 3.18. And I may not know that the base image of my container is Alpine because maybe I got this container from Argo CD or someone else. And Base Image Finder can inspect the layers of that container and it tell you what the base image is and what CVEs might be fixed in a newer version. It can do this from a publicly available image, or you can just give it the list of layer SHAs and it will tell you what the base image is, and it will recommend a newer version of that base image. So hopefully helping folks to mitigate their CVEs faster.
And let's say that there's a world wherein I'm about to upgrade a cluster, but there's a whole bunch of things running in that cluster, and I don't know if it's safe to upgrade that cluster. Should I go? Should I not go? Stevie, what is go, no go?
Go, no go.
Not go. That's funny. Yeah, go, no go. Keep going.
It's like was, not was. Another 80s band. Go, no go is so it's a tool wherein we use our collective expertise here at Fairwinds to essentially create these spec files, these bundle specs that collect all the information we have about upgrade paths for popular add-ons. So things like Cert Manager, external DNS, Nginx, Ingress, things like that. When we see it, we create a bundle file for it that you can then use go, no go to check against your clusters and see if you're going to run up against any of those same issues. So I think that one of the most popular or well-known instances of this is Cert Manager, right? It went through an upgrade where it actually changed the annotation. I think it changed it from a Cert Dash Manager to Cert Manager or vice versa, which affected all the ingress objects in the cluster that were using Cert Manager to create certificates. And so, a tool like Go No Go, you would write a bundle spec for that says, hey, be on the lookout for this, and actually use embedded OPA to scan your cluster and see if you have any objects that are using that old annotation, and then let you know about that so that you would, have a sense of whether or not it's relatively safe to upgrade an add-on or whether there are things that you need to address ahead of time. Because upgrading add-ons is usually a pretty painless experience, but there are times when there are some big breaking changes in charts, and because they're cluster wide, usually if you upgrade an add-on, you can have some pretty big nasty effects especially with like a cert manager and an ingress and things like that.
Yeah. So thank you for staying with us thus far. We got a few more slides to go through, and that includes a polling question. What is the greatest opportunity to improve your Kubernetes environment? Are you looking to just get help with the basics, general best practices, improving your security posture, saving money?
Did Kendall just freeze?
I don't know. Improving the reliability of apps running in Kubernetes is the last option there. So, oh, he froze, but he's got a funny face too.
Yeah.
Oh, he's very excited. Yeah.
All right, we got some results.
Whoa.
Reliability is up there.
Yeah.
All right.
Yep.
Yep. Yep.
Oh no, it's still coming in. All right, reliability and getting help with the basics. Yeah, it's always. I mean, the basics. I feel like we should always. It's not wrong or not like shameful or anything like that to be wanting to get help with the basics, because the basics of Kubernetes are always changing. Like it's
a moving target.
It's a moving target. Exactly. Yeah. With every different new feature that gets released, there's something new to learn. So yeah.
For sure. And the basics can help with your reliability.
That is right.
Good resource requests and limits, good probes, good horizontal pod autoscaling, good cluster autoscaling. All of those things together can make for a very reliable cluster. That's honestly, right. We have been running, fairly straightforward clusters with not a lot of shiny, fancy tools for a long time that have been very, very stable, very, very reliable.
Yeah.
Yep. The basics are the key to reliability, in my opinion. So,
I agree.
All right. Well, I think Kendall's gone. He DM'd me and asked me to talk about Fairwinds and talk about Fairwinds insights specifically. So if you are using a lot of these open source tools that we talked about today and you want to be able to see all of the results in one place and do admission control based on all of those things and get more detailed cost information than you can get from anybody else, then Fairwinds Insights is the place to go. It gives you a ton of capabilities, but kind of the primary ones: cost, policy, guardrails, and we integrate with CI/CD, so you can bring that information all the way back to the developers. That is it for Fairwinds Insights. I did the super quick pitch, but it's software for platform engineers who want to build a standardized and stable, reliable Kubernetes environment for their developers. And you can try that out for free, up to 2 clusters. All the features are available. We don't gate anything. So go try it out for free at fairwinds.com/insights-pricing. That link should be in the chat.
It is.
Thank you. And I'd like to thank everybody. It's been a fun one today. Lots of great comments and questions. Thank you all. And I think with that, I will hand it back to Cody, who's going to hand out some money.
Of course. I'm also half expecting Kindle to pop in while we're closing out, so keep an eye out for that. But Stevie, Kindle, and Andy, thank y'all for joining us today. This was yet again just another awesome discussion, and it's always such a joy to work with you guys. So thanks so much for joining us. I'd also like to remind our audience that this session was recorded. You will be receiving an email with a link to access the recording on demand, but of course you can also find it living on both the Cloud Native Now website at cloudnativenow.com/webinars, but we'll also be hosting it on the DevOps website at devops.com/webinars. And for both sites, just look in the on-demand section and it will be there patiently waiting for you. The 4 winners of our $25 Amazon gift card drawing are Tejaswini M, George I, Segun B, and Aiden C. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way to you in about the next 48 hours. If it doesn't happen to make it, you don't see it, check your spam folder in case it gets filtered out. I'd like to thank Fairwinds for sponsoring our program today. And to our audience, thank you so much for being here. We really appreciate your time, and we do want to just keep you around for 1 extra minute for a survey. As soon as we close out, there will be a survey that pops up, and we want to know what you thought about either this program or, of course, if you have any suggestions for a future program, we want to hear your feedback. Either way, we hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Andy, Stevie, thanks so much for being here.
Thank you.
Yeah. Thank you.